you're actually sitting, congratulations, you're in the right place. So what's really fun is the guy right there, he's the guy talking, and he's going to talk about the stuff over here. If you're in the room, then I apparently have to stay in this box because otherwise I'm going to walk off screen. I did one of the interesting things. I started trying to play with it. I went to one session in person and one session remotely. And yeah, when you wander outside the box, that guy over there, he got lost. So, you know, I'm going to try and stay in the box. I've got a few more minutes, right? Oh, I can start any time. Well, this will be awesome. Let's dig in. So we're going to take Kubernetes for a test drive. Whether you've got some Docker experience or whether you don't, we'll do a quick introduction to Docker to kind of get familiar with it, just so that you know, we aren't surprised by any of the concepts. A little bit about me. I am a Microsoft MVP. I'm a friend of Redgate. One of the things that I'm particularly proud of, AZ Give Camp brings volunteer developers together with charities who otherwise couldn't afford software services. We start building software Friday after work. Sunday afternoon, we deliver completed products. Sleep is optional, caffeine provided. If you're ever in Phoenix, come join us because AZ Give Camp is a lot of fun. SQL source control, that was a lot of fun. Mine is chapter 8. I worked on the Gulp team in version 2 and version 3. One of the things I'm particularly proud of, I posted a comment on .NET Rocks. They read it on the air. They sent me a mug. Woohoo! So enough about me. Let's talk about Kubernetes. Here's the part where I say, I'm definitely going to post this on my blog tonight. You're going to come back to my blog tomorrow. In a week, in a month, in about 3 months, you're going to get tired of waiting. You're going to email me. In about 6 months, I'll reply and say, no, I'm definitely going to post it tonight, and it'll never be on my blog. So you can go to robrich.org right now, hit presentations, and pull up Kubernetes test drive. And these slides are the slides that we will see right now. So you can definitely get ahead. Heckle me about the slides I haven't posted yet. Maybe you can't get internet in here, but the slides are available right now. All of these links are links that will take you to additional content. So that's really cool. So Kubernetes. Kubernetes is an industry standard orchestration engine crafted by Google. What it does really well is auto-scaling and rolling updates. Orchestration engine. Orchestration engine. So what's an orchestration engine? Well, an orchestration engine is this really cool piece of software that, given a set of constraints, will figure out what it needs to do. Given a cluster of machines, you hand it a job like, I would like 3 copies of my server running, please. And it'll go figure out which servers need to run it. So the really cool thing about Docker containers in this orchestration engine is that I don't need to pick which servers in my cluster do what. I hand it to the orchestration engine, and the orchestration engine makes those choices for me. So I can give it instructions like, make sure that my application is running across availability zones. If any of the containers go down, restart them. And so that's really what's phenomenally cool about an orchestration engine, is it will make those decisions for me so that I don't need to. So orchestration engines. Kubernetes, that's the one we'll talk about today. We also have Docker Swarm, DCOS. Azure has Service Fabric, which is also an orchestration engine. And Amazon has the Amazon Cluster Service, which is also an orchestration engine. In the case of Service Fabric and Amazon Cluster Service, they aren't really as exposed to us as the others are. The others, I can just go download them and I can install them on my hardware if I'd like. But all of these orchestration engines do that similar task of, given a bunch of containers, go figure out how to spread them across my cluster. So why did Kubernetes win? I don't know. Google said so. Kubernetes does some amazing things, but we're starting to see convergence on Kubernetes as an orchestration engine. And that's really cool. Instead of having to pick an orchestration engine, we pick Kubernetes, and then we pick the plugins and adapters that we need to be able to run on our particular environment. So Kubernetes will host containers, either Docker containers or, are there really any other containers anymore? Containers aren't new, and Docker didn't invent them, much like Ajax didn't invent HTTP request. But Docker is kind of the de facto standard for containers now. So when we look at Kubernetes, we'll look at hosting Docker containers there. So Docker. What is Docker? Docker is this ecosystem around containers, container virtualization. So what is containers? It's this lightweight kernel virtualization. So Docker is that suite of tools that make these containers run really elegantly. I really love the analogy of XML HTTP request and Ajax. What's the difference between XML HTTP request and Ajax? Well, nothing. But in practice, everything. Ajax is when we started getting sites like Facebook and Google Maps. XML HTTP request powered Outlook Web. And so similar thing, we had containers, but we didn't have this dynamic ecosystem of containers. That came when we had Docker. Docker is this suite of tools that does interesting things. So the obligatory slide of when we talk about virtual machines and containers. I think as an industry, we're almost past this slide, but just in case. Here I have containers, or here I have virtual machines on the left. And here I'll have my server, I'll install an OS, maybe that's Ubuntu. I'll install a hypervisor, maybe that's Zen or VMware. And then into that hypervisor, I'll install a virtual machine. And each virtual machine will be lots of pieces. So I'll install my OS, and then I'll install my app dependencies, and then finally I get to install my app. And if I have a second virtual machine, then I'll install all those things a second time. If we're looking at containers here on the right instead, then we see I still have my server, I have my hypervisor, I have my OS, so maybe that's still Ubuntu, or maybe it's DCOS, and then I'll install the Docker hypervisor, and then I'll install my containers on top of that. Because I'm virtualizing the kernel, I don't need to reinstall my OS each time. So what we see immediately is that I get much denser server utilization between these two pieces. On the one side, I have to install all the pieces, so I only got 3. On the container side, I got 7. I'm using my server much more efficiently when I'm using containers. So because they're sharing the kernel, I need to match the kernel of the host with the kernel of my container. So if my container is running a Linux workload, then my host needs to be a Linux host. If my kernel is a Windows Server workload, then I need my host to be Windows Server. So what's missing? Well, I run Red Hat. Does that mean I need a Red Hat host? Well, I use GNOME or KDE. Does that mean my host needs to run GNOME or KDE? Well, what's really cool here is that the kernel is the Linux kernel. And that kernel is identical between the host and the guest, whether I'm using GNOME or KDE, whether I'm using Ubuntu or Red Hat, or Mint or any other flavor of Linux. Alpine is really elegant here because it's so small. We're virtualizing that Linux kernel. So the flavor of Linux that I set on top of it is irrelevant. What else is missing? Well, I've got Docker installed on my Mac, and you didn't put Mac on this list. Well, yeah, you don't run Mac workloads in Docker. But Docker's still running on my Mac. How does this work? Well, we do this. Here on the right is our production experience where we have our hypervisor installed onto our OS, and we're matching the kernel to the host kernel to the guest kernel, and everything works really well. We have the lightest, most dense footprint. But I'm on my development environment here on the left. And here on the left, I'll have my machine, that's my Mac laptop. I'll install Mac OS. I'll install my hypervisor, and in this case, it's Xhive. That's the default for Mac OS. And then onto Mac OS, I'll install this virtual machine. This virtual machine, let's call it Moby Linux, is a Linux virtual machine, and then I can install my containers into that Linux virtual machine. And that's how we get Docker running on Mac or on Windows desktop, like Windows 10. I'll have my Windows laptop, I'll have a virtual machine, and it'll be that Moby Linux virtual machine, and then I'll install Docker into that virtual machine. So I still have the Docker hypervisor, but I now have a nested experience, which is really cool. So I'm nesting to get more compatibility, or when I go to production, then I go for that denser experience, really matching the kernel with the workload. Any questions so far? So that's Docker. What Docker is from a technical perspective is all of that. What makes it the Ajax of the modern infrastructure is it's ephemeral, isomorphic, deterministic hardware. We have these short-lived machines that are identical. We don't upgrade anymore, we replace. When I have a new version, I bring up my new set of hardware, and I shut down my old set of hardware. When Patch Tuesday comes around, I build new virtual machines, new containers. Ephemeral, short-lived, isomorphic, identical, deterministic, I have a set of steps that will build it. And so I have this configuration as code that allows me to do really interesting things here. So I like to think of it like this. As developers, we look at Docker containers as the inside of the container. Shipping containers is a great analogy here. Inside my container, I can decorate it, I can build my snowflake, I can hang things on the wall, I can put in furniture in whatever way I'd like. Once we close the door, that container is a standard size. And as an operations person getting a container, I can just plug in Ethernet and I can plug in power and up pops my machine. At that point, I'm not dealing with it as a machine anymore, I'm dealing with it as a process. It starts as fast as a process. I can constrain it like a process. And if I want to run more than one, I start the process twice. So this kind of inside the container and outside the container is what makes Docker so amazingly powerful. This becomes a communication tool where no longer am I handing off that big Word document of here's the 10 steps to deploy my application, of which ops goes, yeah, that's nice. I actually had a firm that was really fun. They started sending that Word document in wingdings to see if ops read it. Nope. They were just copying the DLLs into place and hoping it worked. With a container, I've delivered my snowflake in a very elegant and secure way, and ops just plugs it in, and ops is able to treat it as a process. Inside the container and outside the container, this communication platform makes Docker really cool. So let's look at the Docker ecosystem. This is really cool. We start out with a Docker file, and this is configuration as code. In this Docker file, I'll specify the steps that I take to build my application. I'll use Docker build to turn that into an image, a binary blob. And then I can choose to share this image with Docker Hub or pull down pre-built images from Docker Hub. This kind of sharing experience, Docker Hub, kind of similar to GitHub, sharing code. In the case of GitHub, I'm sharing source code. In the case of Docker Hub, I'm sharing these binary blobs. I'll take that image and I'll start it as a container. Now, thus far, we've been using the term image and container interchangeably. I'm going to stop doing that. Container is the runtime version of it. Image is the binary blob. Now, the cool thing is because each image is isomorphic, it doesn't change. The way I start two containers is I start the image twice. So that image on disk is only on disk one time, even if I have 5 copies of my server running. So here's that experience with one image to container. A Docker file builds to an image runs as a container on a Docker hypervisor. I can do the same thing with many images where I start with a Docker compose file and I specify all of the images that I want to build or run. I'll build that into many images and I'll start that as many containers on Docker Swarm or another orchestration engine. So here's kind of the Docker ecosystem, and this is what we're familiar with, and we add Kubernetes. So all of this stuff down here is going to get replaced with the Kubernetes orchestration engine. Now, we didn't lose everything. We still have our Docker file, we still have our images, we have this build and share process, but this run experience and this many containers experience is replaced with a Kubernetes methodology instead. We didn't lose, we gained. We still have Docker build, we still have Docker registries, we still have Docker push and pull. We're going to replace Docker compose and Docker swarm. That's Docker's orchestration engine with Kubernetes mechanisms for orchestrating. Any questions so far? Yep. That is a great question. How does Docker work with domain-joined machines? In short, it doesn't. For the most part, domain joining a container is hard because the moment that I domain join it, I'm going to have an entry in my Active Directory forest for that machine. Well, I expect this machine to live a matter of minutes or hours, maybe days. So I'm just going to have scads of machines, and I'm going to have things joining all the time. How do I know that this container is a valid machine? I don't. There's ways to make it happen, and so I'm not going to definitively say you cannot domain join a container, but it's hard and it's awkward, so in general, we don't. That was a great question, thank you. Any other questions so far? Awesome, so let's dive into Kubernetes. Now, I like to start at the physical layer. Not that we'll deal with it this way very often, but we'll often see really elegant pictures like this, which make no sense at all. So let's dig into the three pieces. We start out with kubectl, the command line, the CLI. We have then master nodes and worker nodes. The master nodes kind of control the process, and the worker nodes then do the process. And it's possible to combine both master and worker into the same machine, and we'll do that a lot when we debug locally. But in production, we'll want to split those out so that we have fault tolerance. If a worker node goes down, we don't want to take down the management of our machine. And then we'll use kubectl as our API into the process. kubectl. Some people like to call it kubectl. The quote that I love is, I'm not sure I want to get that close to my code. I'm not sure I really want to cuddle my code. Maybe that's perfect. kubectl is what we'll call it here today. kubectl is that CLI. So as a developer, I'm going to use kubectl to talk to the master node here in this API server. That API is what is my connection into the process. As I send commands to this API through the kubectl, they will save it to the etcd database, etcd database. etcd database, etcd database. The etcd database will store all the configuration details associated with my cluster, and then the configuration manager will notice those changes in etcd and make determinations about things that it needs to do. Is my system currently matching what my configuration needs it to be? It will notice, in this case, I've sent it a command, it's not. It will tell the scheduler to go make a determination. The scheduler will then pick a node and tell that node through the kube config what to do. This kubelet is the control per node. So here's one worker node, and here's a second worker node. That kubelet receives those instructions from the scheduler to do things. So the kubelet then will schedule pods, start pods. CAdvisor is interesting. CAdvisor will watch the pods, gather statistics, and save that back to etcd. And then we have a kube proxy. As a user, I'm going to come into my service, and my load balancer will pick which node that I'm sent to, and that will forward into the kube proxy. The kube proxy then will pick the correct pod and send my traffic through. The CLI, the master node, and the worker nodes. That's likely more detail than you want to know about all those pieces ever again, But understand this, Kubernetes gets microservices. Kubernetes is built as a microservice architecture with all of these pieces. The master node has the scheduler and the etcd database, and the client has the kube controller, the kubelet, and the cAdvisor, and all of these pieces work really well together to do interesting things. Any questions so far? So, installing Kubernetes. Don't. Sorry, just don't. Installing Kubernetes is hard. Let's look at other options. On a public cloud, Azure Container Service, AKS, I want to say it's Azure Kubernetes Service, because there's also another Azure Container Service, ACS. We want to pick AKS, a managed Kubernetes instance. Amazon has Elastic Kubernetes Service. Google has the Google Kubernetes Engine. And then if I go into the private cloud, Mesosphere, OpenStack, Cloud Foundry, each have mechanisms for running Kubernetes clusters as well. And for the most part, if I want to get going with Kubernetes, I'm going to reach to one of these managed providers where they've already done that hard work for me. The beauty of Azure Container Service, AKS, is that I don't pay for the worker nodes. I don't pay for the master nodes, I only pay for the worker nodes. I only pay for the things actually doing work. So those master nodes that are keeping track of everything, the etcd database, all of the API server, all of that content is managed for me, and I don't need to worry about it at all. I only manage my worker nodes. And that's kind of nice. That's kind of becoming the thing, and Amazon and Google are kind of moving in that direction as well. So I can, in theory, have a cluster running with no worker nodes and pay nothing. And I love that. So locally, we have two options that are both wonderful. If I use Docker for Mac or Docker for Windows, on the edge channel in Linux mode, then I get Kubernetes. So I'm running Docker for Windows on my machine. So here I'll go into settings. I'll choose Kubernetes. And I turned on Kubernetes. And now I have a Kubernetes cluster. I did nothing else. Our other option is minikube. And the really cool thing about minikube is that minikube is that development environment single node cluster built by the Kubernetes team for exactly this scenario, local development. Single node cluster, so the master and the worker nodes are both on the same physical machine. That machine happens to be a virtual machine, and so then I can launch that minikube virtual machine by passing in my virtualization driver. On Mac, I'll pass in Xhive. On Windows, I'll pass in Hyper-V, and then I can pass in the Hyper-V switch to say, I would like you to start this minikube in this way, give it this much resources, and away we go. So I've got then Kubernetes running. If you really, really, really want to install it, by all means, don't let me stand in your way. Here are some other hosted solutions, and I think this is really cool. Google Kubernetes Engine, Amazon Elastic Container Service, and Azure Container Service. We talked about those, but there's quite a few more. Here's some OpenShift details, IBM. There are lots of ways that you can run Kubernetes on the cluster of your choice. If you still want to install it, by all means do. You'll want to look at kubeadmin, or look to kubernetes.io/docs/setup. As you look at these slides later online, robrich.org, you can go to that link and just click it and open it up. It's a little bit hard to click on the video. So that's how you get Kubernetes started, and that's kind of the physical layer of how we deal with it. But that's probably the last time we'll need to worry about those pieces. Let's worry about these pieces instead. So here are kind of the main elements of how Kubernetes does its thing. We have pods, we have deployments, we have services, and then we have a bunch of others. We'll talk about pods, deployments, and services today, but we also have ingress, replica set, stateful set, job, cron job, secret, and I tried to do this thing and I kept finding another one, and so this list got long enough that I'm like, okay, let's chop it off there. These are kind of the native elements when we look at it at the logical layer of how we interact with Kubernetes. So each one of these is described as a YAML file or a JSON file, but typically a YAML file. And that YAML file then contains 4 main elements: my API version, the kind, metadata, and a spec. The kind then will be, pod, service, deployment. The metadata will be, information about it, the name, labels. We're going to come back to labels. That's going to be fun. And then the spec is like all of those details about it. So here's a pod definition, and this is really fun. Here's that pod definition. My API version in this case is version 1. My kind is pod. My metadata, I have name and labels. And then my spec, here's the details that identifies the parts in this pod. And so this pod has one container in it, and that container is Nginx, version 1.7.9. And that Nginx container then lives inside this pod. And the pod will forward in content from port 80 into the container. If I squint real hard, this kind of looks like a Docker Compose file. That's kind of cool. That pod is our unit of scale, our unit of deployment. As we look about, can I run this thing, I want to look about launching a pod with that content in it. Now, the rule of pods is 1 container per pod. The rule of containers is 1 process per container. So I want to look at that microservice, and I want to pick the right seams in my application so that I have 1 logical unit of work there in my pod. Now, optionally, I can put sidecar containers in there to do interesting things like harvesting logs or analytics or statistics. In general, no, you don't want to put more than 1 container in a pod. When you get to that point where you understand how sidecar containers work and you understand the needs and capabilities there, then when it presents itself, you'll know the right time to add a 2nd container into your pod. Until then, 1 container per pod is perfect. Because it is that unit of scale, that unit of deployment, if I packed all of my containers into 1 pod and I needed to turn up the volume, turn up the scale, I would turn up the scale on all of them simultaneously. Really, I want to be able to do that at a much more granular level. And then also the pod describes those Docker details, the Docker image and ports. So deployment is that next level that talks about how many pods do I want to run simultaneously. And this is across the cluster. So in my deployment file, I'll say, for example, here, I would like 3 replicas of this pod. So as you start up this deployment, launch 3 of them. And what's really cool, here's that template. And this template is, in effect, a pod file. I'm saying, here's the pod definition that you should use every time you start up one of these 3. And so, yeah, there's my Nginx image, and away we go. It will then start up that image 3 times. A note about deployment API version, because this gets a little bit hairy for me. API version in Kubernetes 1.9 and greater is app/v1. In version 1.8, it's app/v1 beta 2, and so on. I'm running in Kubernetes 1.92 as part of today's demo, and so I'm going to use app/v1. But you may need to change it. It's backwards compatible, so if you just want to say extension/v1 beta 1, you'll be fine forever, as long as deployments were supported. A service then represents the inbound traffic to our pod. So the service will define things like how data gets from other pods into this pod or from external content into this pod. So here's a service YAML definition. I have API version 1, it's a kind of service, and I would like to have node port coming in on port 80. A note on these types can get a little hairy, so I pull these out specifically. If I don't have a service, then I don't have any inbound traffic to my pod. And maybe that's fine. Maybe I have containers that are doing isolated workloads where they're pulling data off a queue and processing it and pushing it back on, in which case I don't need a service at all. If I do have a service, node port will get me a specific port on each node, which is really elegant. Cluster IP will get me a free internal port on the cluster, so it'll go randomly find a port and assign it there. And then load balancer is specifically cool because it will go reach into the cloud infrastructure and provision a native load balancer. So when I'm on Azure building in Azure Container Service, and I say my service is of type load balancer, I will get an Azure load balancer. Charges will apply to accomplish that, but I'm not getting this, fake load balancer. I'm actually getting a real Azure load balancer. The cool part about the rest of these is they also have load balancing capabilities built into Kubernetes, and so I can get kind of a similar round-robin DNS experience with, or round-robin experience proxying with these other pieces as well. But then when I go to production, load balancer is perfect. The bummer is that load balancer isn't available on minikube. So now do I need two different service definitions, one while I'm playing and one while I'm not? I wish they would implement a load balancer in minikube so that we didn't need to do that. So we set aside labels for a moment. Let's come back to that. In each of these pod and deployment and service YAML files, we had labels. In my service, I have this selector that says go find app nginx, key value pairs. And in my pod, I have labels app nginx. How do I know which pods my service applies to? It will go find all the pods whose labels match, and those are the pods that it will control. Those are the pods it will forward to. So if I have more labels on my pod, that's totally fine. But if whatever labels I specify here on my service, those are the pods that it will forward to. So I can describe my pod in interesting detail. I could say app is nginx. I could say version is 1 or 2 or 1 point whatever. And I could do other labels on my pod. And then in my service, in my selector, I will match the labels that I care about. Any questions so far? Well, let's go do this. This is really fun. So I have here a Docker file, and I'm just pulling from nginx Alpine. I'm copying in this index.html into my container because the nginx Alpine image already has the content that we need in the startup details. I don't need a CMD line, and so I can just say in here, docker build -t let me go grab the name of this image. Kube demo, docker build -t, kube demo v1, source. And it will go build that container. I've built it previously, so we see that this was really fast. It was cached. I'm building it on Windows to build a Linux image, so I get this wonderful warning that explains to me that ACLs are different than users and groups. Thanks, Docker. And now I have this Docker image list. Now, I built kube demo, and I pulled a few other things. But you see that in my list, I also have all of the Kubernetes images. Docker container list. I don't see those running. Well, they're running in Kubernetes, but they're running in a different namespace, so we don't actually see them by default. Here in our settings, we had the option to expose the other namespace, and in this case, we chose not to. So I've got my Docker image, and let's build a pod. Here's my pod. I've got the kind is pod, the name is kube demo. I've got some labels on it that just make that more descriptive. Here's my spec, the containers. I have a single container in there, and it's going to use that kube demo v1 that I just built. So I'm going to fire up kubectl, kubectl version, I'm seeing that I've got 1.9.2. kubectl cluster info. Here's some details about my cluster. It's running locally inside the virtual machine, but Docker for Windows is proxying it automatically, which is really wonderful. So I'm going to say kubectl apply-f that pod file. I love this, where I just say, here's my definition, go make it happen. That pod was created. kubectl get pods, and I see that my pod is running. I can do some interesting things. kubectl logs, pods, kube demo, not pods. And I can see that no console output has been generated from my pod. No inbound traffic is there. kubectl delete-f kube pod.yaml, and my pod is gone. We started a container. We did all of the things. It was running in our Kubernetes cluster, and away it goes. That was fun. Any questions so far? Great question. When I did that kube apply, did it start the container? Yes, it did. Yeah, so that container was running and doing all of the things that the container would do. The Kubernetes CLI. Oh, any other questions before we dive in? Good question. When I did this kube apply, I referred to the YAML file. And then when I started trying to get details about it, I referred to the name. Why the difference between the file and the name? Well, in this case, the pod YAML file defines how I'm going to craft my pod, how I'm going to create it. Once I've created one, I may have created more than one, and so I'm going to reference it by name of the one that I created. As we dig into deployments, we'll see that we'll spin up many of them, and the pods then will have unique names for each one. And then as I delete it, I could have chosen to delete it by YAML file, or I could have chosen to delete it by name, because I had both available. Let's do that. kubectl apply-f kube pod.yaml kubectl get pods. There's my pod that's running. kubectl delete kube demo. Oh, pods kube demo. Okay, so that pod is now deleted. Why the difference? Because that's kind of how it works. We see similar things when I'm talking about Docker build and Docker run. Sometimes I'll refer to the image name and sometimes the container name. Deleting pod.yaml would delete all instances. Not necessarily. It deletes all of the resources that I've defined there. In this case, because the YAML file only defined one, yes, it would delete all one of them. But if I started up this pod many times and got many different pod instances, deleting it by file would only delete the one that matched the name here. That was a great question. Thanks. Is there a way to delete all instances of the pod that's defined by that YAML? That is a great question. Ask me again when we talk about deployments. So the Kubernetes CLI. We saw a few things dealing with the Kubernetes CLI. These details will be great as you pull up the slide deck on robrich.org, because all of these are then available to you. kubectl version and cluster info, we saw those really quickly. Those are great for administration. kubectl apply-f and that YAML file. will either create or update the content of that. There is a kubectl create, but that will then try to create a second one. And I generally have the definitions in my YAML file just so, and so when I create it, I want to create it or update it. And so this upsert with apply is really, really elegant. Some more things about getting things. We did kubectl get pods, but we could also get services, deployments. Here we're getting pods, services, and deployments. Or we can just say get all. And the beauty then of get all is it will get all the things, including all the other things. And then I can also say dash dash all namespaces, which will show me the other things that are running in Kubernetes. That's the mayhem that Kubernetes is doing behind the scenes, which is wonderful. I don't have to worry about that. But yeah, they've got a few things going. So let's launch some apps. I have this pod.yaml, and that kind of describes how I want to build this pod. And I want to build a deployment that will build many of those. So here in the template section, that's exactly the pod definition, with the exception that I left off the API version in kind, and I didn't specify a name. Because I want, as it crafts this, to be able to craft many of them. In this case, I asked for 2. And then other details about how I'm going to pick this. I have some match labels so that it knows that these are all of the pods that it started or needs to control. And then that matches the labels here to say, as you define them, label them correctly as well. So I have this deployment that will start up 2 instances of this pod. And then I have a service that will specify inbound traffic. In this case, I've chosen the type node port, so I'll have a specific port on each node. I only have 1 node, so that's perfect in this case. I will say take port 80 content and pipe it into port 80 inside the pod. kubectl apply -f deployment and kubectl apply -f service. Now, because of those labels, I could start it in any order. And if I hurry, I can see them starting up, and I didn't, so they're already running. But I can start them in any order because of those label matches. So if I start the service first, it'll just say, hey, I've got no pods to control. Congratulations, you get no content. I asked for 2, I've got 2 of these pods, and now they have really interesting names. What was your question about deleting all the things? If I specify that I would like to delete my deployment, I will delete all pods that that deployment created. And that's the way that I pull down all the pods. Let's not delete them yet, because we've got some deployments up. kubectl logs this pod. And so far, we don't have any content in the console output. That's OK. kubectl describe that pod, and we'll get all kubectl describe pods. We'll get all kinds of interesting details about this pod. So here's the logs of as it started that, that pod. We have some additional details. Here's the Docker image layer name that it pulled. Here's the image ID. Here's the labels that I started it with. So app equals kubedemo. I specified version equals v1. And it added this pod template hash equals blah so that it can find it as well. kubectl get all. kubectl get describe svc kube demo service. There's 2 C's in describe. Thank you. And now I need the SVC back. There we go. So here is the service that I applied. Here's that initial configuration. It flipped it into JSON. That's fine. And one of the things that Docker for Windows did for me is it actually put in an ingress controller of localhost on this. So not only do I have port 80 set as the node port inside my cluster, it also gave me this port, 30279, externally. Localhost 30279, and there's my pod. Woohoo! We got to the pod! I'll refresh that a bunch of times. We are running traffic in Kubernetes. kubectl logs for this guy. Nope, that wasn't the container that got it. Let's look at the logs for this guy. There's the console output that we got from Nginx as we were hitting that site so many times. The beauty is those logs are no longer in the container. They've gotten piped into Kubernetes, and I can now send them elsewhere as well if I'd like. You want to hack my box, pop my box, and do interesting things? That's fine. I know exactly what you did. So we've got our service. The service allows inbound traffic into our pods. The deployment then specified the details of those pods. And so currently we have 2 pods running, and we're able to hit them. Any questions so far? Why did they go to the same instance? I don't know. That's how Kubernetes chose to apply it this time. In theory, it's a round-robin load balancer, and so I'm surprised that it hit it all on the same one. Perhaps it's that one that it chose for these bursts of 8 or 10 requests, and then the next 8 or 10 would go to the next pod. You know, ultimately, if I wanted more control over that, I would switch my service to type load balancer and let my cloud configuration dictate how that load balancer would behave. But this service's load balancer is kind of a naive implementation, so it worked. Yep. Why would I create a pod YAML file if I have all of that content in the deployment YAML file? I agree. I didn't start the pod YAML file. That was our stepping stone of how to understand the template section of the deployment YAML file, but I agree. In a production app, I would never create a pod.yaml file. Great question. Is there another question? Yep. I'm not quite sure I heard that. The YAML file details of the service? Mm-hmm. Oh, good call. So I want to create a service for my web application, and then will I also need a service YAML file for my backend API? Yes. Any set of pods that you would want to expose, whether to the cluster or to the public, you would need a separate service definition. So typically I have those pairs. I'll have a set of deployments for each. I'll have a deployment YAML and a service YAML for each microservice. And so those will describe the Docker container details, and they'll also describe the exposure details, how I choose to expose that microservice to the rest of the thing. My API will have a set. My website will have a set. Other microservices will have a set as well. And at that point, then the major difference is this type. I'll choose cluster IP or node port instead of load balancer for my internal services. So we've got our Kubernetes app deployed. We started to poke at some of these tools, which is really elegant. kubectl logs and kubectl describe. I point out kubectl exec and attach only because it's slightly different than Docker. In Docker, when I say kubectl exec, I now get an interactive experience. In Kubernetes, exec will run this thing. And once it finishes running this, it will exit. If I want an interactive experience, then I attach, and now I have a shell that I can poke at. So one of the things that Kubernetes does really well is the rolling updates. kubectl rolling update, and we also poked at kubectl delete. Let's go do a rolling update. So I have this deployment, and it's doing great, and I have this website, and it's doing great, but I have a change to my index.html, so I just have a new folder where I duplicated all that content just so that I could see the things. I don't have a change in my Docker file, but as I build my Docker file, I'm going to call this kubedemo v2. So here in my deployment, I changed literally two things. I called this version v2, and I called the image kubedemo v2. So I just updated my deployment file. So I'm going to come in here to my folder, and I'm going to say kubectl apply-f deployment.yaml. And if I hurry, I can see these ones terminating, and then these ones starting up. And now I flipped to my new deployment. I'm now running version 2 of my app. My service didn't change. My pod switched. I'm going to hit the exact same URL, and now I'm running version 2 of my website. Woohoo! We did a rolling update. What was really cool about that is that not only did we do that rolling update, but we did it with no downtime. We watched how it started the new things, validated that they were healthy, and once they were, it started killing off the old things. At no time was my application offline. Now, I could have said kubectl delete-f deployment, kubectl apply-f deployment, and yeah, I would have nuked everything, started over, and created it. But because I said apply, I got version 2 with no downtime to my users. Yeah, some users are going to get this weird experience where, like, they're on the old one, and then suddenly they're on the new one. That's okay. Yep. How does it know that it's running? In this case, because I have this naive implementation, I haven't put in place the health check. But yes, I can do a health check. I can do a liveness probe. I can also do a readiness probe to say, how do I know when this container is ready enough that I can start sending traffic to it? And then the liveness probe, how do I know that it's still running? And so based on those details, then Kubernetes can say, this container's garbage. Let's throw that away and spin up a new one. Yep.
Maybe outside the scope, but is there anything Kubernetes supplies for doing canaries or rolling windows or anything like that?
Is there anything that Kubernetes does for doing canary or rolling updates, A/B testing? I'm sure there is. I haven't played with that. For the most part, when I want version 2 up, I want version 2 up. But yeah, I've seen some interesting things done with labels and starting to turn traffic up. I haven't played with it personally, though. So Kubernetes has this really cool thing that is really wonderful and really scary. If I say kubectl browse, then I'll be able to get to this dashboard if I've chosen to install it. Now this dashboard is really cool, and I can discover all of the pods and all of the services and deployments. I can even create things, I can adjust them, I can change the image, I can turn up the number of replicas up or down, scaling my service, and that's wonderful. Here's the word of caution. None of those details were in my YAML files. So next time I kubectl apply, I'm going to wipe out all of those changes. This dashboard is pretty, but warning, it's really easy to change things in here and then get those changes rolled back. Technically, there is a way to get Kubernetes to pull the current configuration and in YAML or JSON format, and then I could, capture the changes that came from the UI. But as I do that pull process, I will also get all of the default values that I haven't specified here. So then my YAML files become much more verbose. Maybe that's fine. Probably not. So I would argue, though this UI is very pretty, get comfortable with the kubectl command line and keep your current state versioned in these YAML files. So we saw kubectl. We saw the master node doing interesting things. We saw the worker node. We saw how we could spin up deployments and services and how we could then route traffic to it and then be able to do this rolling upgrade where we had zero downtime. Ultimately, Kubernetes is this container orchestrator for the modern web. This is how we build apps today. Any questions? Yep. Why would I pick Docker for Windows versus minikube? Minikube has a little bit less hardware requirements to start up. And so if I'm trying to get up quickly, minikube might be my best choice. Docker for Windows with minikube installed, if I need that Docker build and run experience, then I would probably choose that one. If I have enough hardware to do it, I generally lean towards Docker for Windows instead. Thanks for coming, everybody. I will be on the Slack channel, and I have the Slack channel. Thanks for coming.